So basically, yeah, just provide background. AI Authority, we're obviously a podcast that's basically trying to interview and learn ourselves about artificial intelligence. I think Will, my cousin or co-host as well, we're sort of just starting out, and yeah, we just thought we'd reach out to a bunch of different companies who are in kind of AI, or I guess, in your case, it's very interesting with, I guess, like the intersection between, I mean, essentially, the CL1 is the first commercial biological computer, which has been launched by you
Yeah.
guys. So I would love to start off by, I guess, firstly learning about your journey at Cortical Labs, and then maybe moving to just a broad explanation of Cortical Lab.
Yeah, I've actually joined Cortical Labs fairly recently, but
Yeah,
I have been aware of the company for quite some time, and in fact, all the way back maybe 6 years ago to their earlier days.
yeah,
And where I come in is that I was a stem cell biologist researching
saw that.
neurodegenerative disorders like Alzheimer's and that sort of thing.
Yeah,
And what really drew me to Cortical Labs was seeing neurons playing Pong, right?
yes, saw
So,
this.
so, so seeing the neurons learning to play Pong was amazing to me because suddenly there's a way for us to measure cognition, if you like, or learning ability in cells, which is when you're talking about disease modeling, that's a really strong, powerful tool because then you can start seeing how diseases affect that, and then how that affects that learning. And then if diseases affect that learning, then you can start using drugs to test to make that learning better, if you like. So it's like looking for how diseases like Alzheimer's might detrimentally affect the system. Then you can cure that system.
Right. So because the
That's
way it works, is like you take it's a blood sample you take, is that right? And then you put it transform it into a stem cell, or something like that. I'm
yeah,
not
yeah, yeah.
very,
It's yeah,
yeah, yeah.
it's I want to say it's brand spanking new technology. It's been around for about 20 years now.
Oh, okay, there you go. Okay.
Shinya
Yep.
Yamanaka, Professor Yamanaka, he won the Nobel Prize for
Oh,
his work in discovering this.
saw this.
So what happens is, yeah, you can take blood or a bit of skin. We
Yep.
use blood.
Yep.
And what you do is you're putting a combination of usually four genes
Yep.
into the cell, or four proteins, and you
Yep.
make the cells make these proteins. And what that does is it turns that cell backwards into a stem cell, the earliest, like some of the
Okay.
earliest points of development. So
Yep.
it's so equivalent to an embryonic stem cell.
Yep.
I'm not going to go deep science because there's a whole bunch of differences if
Yeah.
you really want to talk deep biology.
Yeah.
But
No.
essentially, that cell can now become any cell type in the body. Okay.
Okay. Okay.
So that's stem cell. So from blood, we can go anything. Now,
Okay.
what's really good is that we can actually then take those stem cells and make neurons, and
Yep.
we can make different kinds of neurons and
Neurons in
different
the
parts,
brain. Neurons from the brain.
neurons in the
Yeah.
brain,
Yep.
neurons in the brain, neurons in the body.
Yep.
So like your peripheral nerves, your nerves in the brain, and there's all these different types of nerves in the brain or neurons in the brain, and we can make different types or most of the different types.
Yep.
So this means that we can really investigate different functions of neurons in the CL1. Okay, so
Yep.
what I'm talking about. I'm coming at this from an absolutely pure biology perspective, and we
Yes.
haven't even touched on the technology perspective yet.
No, that's right.
So if you think of it, all right, so from the biology perspective, it gives us a tool to study biology. It gives us a tool to study pathology of disease, right?
Yep.
And then to test drugs on those diseases. So a really powerful tool to interrogate disease and find drugs. Great, that's awesome. That's a very straightforward application of the technology.
Yep.
Sort of, if you like, it's like your short term or your low hanging fruit, where however you want to phrase it.
Yep.
I
Yep.
think low hanging fruit doesn't do it justice, but it's yeah, it's certainly the most immediate and straightforward application of the technology. From there, we
Yep.
can start branching out into more the technology side. So, for example, you could use CL1 and it's closed loop that has the learning with Pong or whatever environment you'd like, whatever environment you come up with, you can make your own. So what that can just start doing is you can start using it for things like um, it's like a front end for machine learning, right?
Yep.
You could use that as so for example, you could train like large language models through the neurons, and then go to the silicon, if you like, for scale for larger scale. Now, The reason why I say you could train through the neurons. Now, why would you want to do that? Well, what we've found is that the neurons are really good at learning.
Yeah.
Okay,
Like the same
and
neurons that are in our brain, for
yeah,
example.
yeah, yeah,
Yeah,
yeah,
yeah.
yeah. So think about it. There's millions of years of evolution
Evolution. Yeah,
to that have made these cells that are designed to learn, designed to
that's
react
right.
to their environment, right?
Designed to survive. Like otherwise we
And,
wouldn't be here today. Yeah.
and there's no way that 70 years of electronics or chip design can beat millions of years of evolution. But we are seeing that the neurons can, or the nerve cells can learn faster from less data than your traditional large language models, like your institutional silicon models.
Well, that's
So
right.
that's why
Yeah.
we say that you could use nerves as the front end, or the neurons, and use them to train on less data faster and feed that into like a large language model system. That's the
But
potential use.
but a large language model itself can't even. It's obviously not AGI yet. Like it's not artificial general intelligence yet.
No.
So it's almost like a prediction machine. A very good prediction machine is my understanding for an
Yes.
LLM. Yeah. At the
Yes.
moment. So
So,
yeah.
and you're also constrained by energy use and size and all that sort of things. And the neurons are optimized for learning and have a very good energy, very efficient energy usage. So that means a lot less energy required to get
And
them to do their job.
I heard that like the brain itself, I don't know if this is right. I heard it a while ago, but don't we only have the energy consumption of a light bulb or something like that? Or I don't know. There's
It's I don't know off the top of my head, but it's something like that. Yeah, it's
yeah, it's
very
something. The energy efficiency of our brain is ridiculous, and
yeah
obviously, yeah, we've used
yeah.
that to have every breakthrough.
But if
I
you're
mean,
if you're if all the biologists out there will be going, yes, we're talking about Krebs cycle and mitochondria and all this sort of stuff going on inside the brain. Respiration. It's all geared to make energy, right? So um yeah, so I mean we're harnessing that ability and the ability of the neurons to learn. Now, if you want to compare like silicon-based technology to the biology component, you can't really directly compare them as such.
no, yeah,
But what I can say is, you got your energy efficiency, you've got your adaptability of the biology, right? So because these are designed to learn, they're like cells want to learn. They want to react to their environment. They're their plasticity, so they adapt to what's happening around them, right? Whereas
exactly, yeah,
silicon is fixed, right?
exactly,
It's
yeah.
very predictable, very reproducible, but fixed. So you have to put a load of data into that to try and get it to do what a neuron could do. And a
Which
lot of the chip architecture, they're starting to try to mimic what neurons do.
yes,
So I guess
but
at
that's
Cortical Labs, we're like, well, instead of trying to mimic neurons, why don't we just use neurons, right? So
yeah.
that's
But this
yeah.
seems like I don't know if I'm jumping the gun here, but it seems like we're closer here at Cortical Labs with this sort of link between the neurons and the silicon to AGI than we are at ChatGPT at OpenAI when it's just pure. I don't want to say something crazy, but like
Yeah,
it
well,
seems like that.
no,
Yeah.
no, 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 no. I guess you're. I guess one of the big differences is that if you consider what AI is in terms of the software, the hardware,
Yeah.
and think that really all started 70 odd years ago.
Yes. Yeah. Yeah.
With the first chips and things, and think about how many trillions of dollars have been invested in that
Oh, so much.
over
Yeah.
that 70 years, and where we're at now with the biological computing is like what we're maybe 6 years in with
Oh,
millions of
really?
dollars perhaps of funding. So you got to think what's this technology going to be like in 60, 70 years with a lot of investment.
Wow.
So we're
So
really at the beginning.
is this like I think there was a couple of like world firsts or something, I don't know, in Melbourne, but is this like say is there same similar labs like Cortical Labs over in the States, or is this kind of
Well,
yeah,
I mean, there's it's a very niche scientific area, right?
yeah,
So there are labs that look at this, certainly publish on this. We're the first people to make the technology and the system available commercially.
yeah,
So if you have the know-how how to grow neurons, and there are quite a lot of people around the world who can do that sort of stem cell to neurons work, you can do that. You can just buy a unit off of us and go for it, right? But not everyone has that capability. So what we've
And
done is we've aimed to make the technology as accessible as possible. So that's why we have the Cortical Cloud. So that's where people can log
ah,
in via the internet, log in, have access to a machine with neurons on it. They don't have to worry about looking after the neurons. We do that bit. All they have
yeah.
to worry about is hooking into the system and doing their experiments.
It's a
So
neuron
that's
as a service, neuron as a service system or something.
yeah, we
Something like
call
that.
it like where as a service or lab as a service if you like. But
Yeah.
yeah, where as a service is certainly a term that we use.
And so,
So
what do
that
you?
really
Yeah, sorry. I was going to say
that
what?
really just makes it that means anyone can get access. You don't
It's
have to
awesome.
have the specialist stem cell skills. Um, the stem cell guys might be going, "Hey, we need someone with technical skills," but so it's we can help on that too. But yeah, it's that's what we're aiming for is to make the technology accessible because by doing that, then the technology can grow. Right, we'll start
100%.
seeing. And the more it goes out there, the more it gets worked on. Then you start seeing that development curve really go steep. Yeah,
And
just
what?
like you would
And
see with current IT, right?
100%. And then what are some of your customers like? Out of curiosity, you don't have to like mention names or anything, but what
Yeah.
are some of yeah? What are some of them doing at the
Um,
moment?
Surprisingly, like I was purely joining the company. I was expecting to be a whole heap of biologists,
Yep.
like not in terms of inside the company, but in terms of the customers. And
Yes.
certainly
Yes.
there are a lot of people in the biology or the medical field. Um, then surprisingly, there is a very big interest from tech,
Yep.
um, just because it is a new way of computation, if you like, and it's at the very start. So there's a lot of people very excited because it's just really beginning.
Yep.
And getting in at the start, obviously, brings in all sorts of opportunities. But also you find that people are also looking at this as possibly an alternative to traditional computation that's really sort of energy intense and
Yes.
maybe not sustainable in the future. We also get interest from pharmaceutical companies for obvious reasons with the drug discovery potential. Um, Artists as well,
Really.
musical artists, and other art forms because they want to make use of the biological aspects of the neurons, the creativity side of things, and so they want to
Yep.
use the neurons to be involved in artwork or music production or that sort of thing.
Oh wow.
So, I mean, AI already does that, but they want to make use of the ability of neurons to react to new situations or to be adaptive to new situations, which happens quite quickly for neurons, not so much for traditional AI.
Yes, because yeah, like sort of we mentioned before, the way I simply understand an LLM or AI as it stands is just it's a prediction machine. It trawls the internet, it reads all these. This is very simplified, and I'm sure you can. it,
Well, I mean, look. I mean, AI in the AI model is trained on sort of like tokens, if you like,
yep,
of data.
yep,
Maybe trillions, maybe billions. It depends on the company and how deep their pockets are and
yep.
how much technology they're going to running. So maybe OpenAI uses trillions of tokens to train their systems, but it is largely brought in from the internet. But you got to do all that training. You got to do the fine tuning, and then you still got to make sure it works, right? So
And then it gets thrown
I mean, we all know. I mean, we've all used
yeah,
ChatGPT and sort of you get some weird outputs from it, and
yes,
that's just a matter of how you've prompted it.
yes,
What have your other prompts been? Have you prompted it with something that maybe isn't that common, so it hasn't really seen it before? So that means then it's harder for ChatGPT because it hasn't really seen it before. It's harder for it to try and make sense of it. So it's so you're right in that it's kind of like a predictive model
yeah,
in a way, but yeah, it's really about it can only do what it's been trained on,
yes, exactly.
and the neurons we can train and they can adapt to the training. We don't have to tell them exactly what to do. And really, the I suppose the challenge is for that is that you know what can we actually do with the neurons? I mean, it's really an open playing field, right? We don't know how far this can go. We know what we can do with it, right? In
What is
terms
its
of
current
training to
capacity?
play games or
Yeah, yeah.
well,
So
its
its
current
current
capacity
capacity.
is you can use it as you can use it as a tool to study learning, and we can make
Yep.
the neurons learn. And then beyond that, well, how many different ways? I mean, what can we actually make it learn? Like how complicated can we get? Common
Yes,
one
exactly.
is common question is, can it play Doom? Which is a
I know, dude. Yeah, I used to
funny
play
one.
them. Yeah.
And actually, like we had a hackathon a couple of weekends ago where the challenge was for the people who participated was to come up with a way to make it play Doom. So
That's awesome. I love that. How'd it go?
there's a bit of fun involved, but this is what I'm saying. Like we don't really know where the ceiling is. I mean, it's all about ideas, and it's about people coming in and saying, "Hey, I'd love to try this on the Neurons, right, or on the
Yeah.
CL1." And what I mean, there is actually a picture that I've seen floating around. So from way back in the 70s when Apple released their first home PC,
Yeah.
there's a picture because Apple didn't know what people were using the home PC for. Actual,
No.
they had no idea what people were actually using their computer for.
Yeah. Yeah.
So there was an actual advertisement. You might be able to find it. Where there's someone there holding like an Apple computer, and the question is, it's the best thing since Adam's apple. What do you do with yours? It's so they were actually
Yeah.
asking, instead of advertising this is what it can do, they're saying, hey, what do you do with it?
Right.
You
Putting
know,
it on
so
there.
so it's almost like that. It's like,
Yeah.
all right, we know it can do this stuff. What do you want to use it for? What can you do with it? What
Yeah.
idea do you
Exactly.
have that you want to
What creativity?
that you want
Yeah.
to explore? Yeah. And I
Um.
mean, like we don't take people's data or anything. So if someone's got a good idea to do something on a biological computer and has some fantastic idea that they then patent and make millions and millions of dollars, go for it.
But I mean, that's the same with like,
So
yeah, that's the same with like a Mac. I mean, yeah, like you have the computer, but then you have like all these different like applications, like basic
yeah,
things like Excel or Word or whatever, like email or, photo booth, or there's a million things like you can do
yeah,
on it. And it sounds like that's the same thinking that we need to apply to what you're doing here at Cortical Labs.
yeah,
Um,
absolutely, absolutely,
yeah. And you're creating the space for that. So, I mean, that's awesome. I
yeah,
feel like, I mean, it's sounding like this is kind of very much in its infancy. I mean, as you say, it's only been the last 7 years, but I mean, like I said, it feels like more of a bit of it's closer to, I say AGI, but it's closer to being able to understand things that an LLM perhaps can't with with neurons just, acting like the human brain, which is something we can just learn and sort of think
yeah,
laterally. Yeah.
yeah. So I mean, like there are pros and cons to both silicon and neurons, but it's the way they handle information, right? So the
Yes.
biological computer will handle information differently than a silicon computer. And we're sort of taking the biological part. I mean, by having a biological computer, we're combining obviously the biology with the silicon, but we're harnessing the way neurons handle information to get an outcome, right? That you can't do with traditional silicon. Okay,
Yes.
we're harnessing that. We're harnessing that um, innate biology to be able to learn and to be able to react to situations, even unfamiliar ones. As soon as you start giving them information and feeding information to the neuron, they start adapting, changing their networks, changing their connections
Yes.
to
So
adapt
then,
to this information.
so how do you see that going over the next 5 or 10 years? Or maybe it's too early to even assess like how where it could go, where it
Uh,
could go. Yeah.
I mean, as I said, certainly the earliest applications are, and the most immediate applications are for disease modeling, drug discovery. So we'll
So
see benefits in. I mean, the number of drugs, especially for the brain, that fail at clinical trial is phenomenal
really,
because the
yeah.
models aren't there to be able to study it. So this provides a
Yes.
really good model to be able to study for those drugs. That will almost certainly be the biggest the biggest advantage of the system in the immediate term. And then as more uptake is happening, I think we'll see it integrate more with large language models. Potentially, we'll see it integrate more with environmental modeling
Yep.
or even defense,
Yes.
where where when you have unfamiliar or situations that require very fast reactions without much data to go off. That's the sort of
Yes.
things where the AI will, so the SBI, I should say, the biological intelligence or bioengineered intelligence, will really excel. And I'm not saying that we're going to have like jet fighters flying around with
No.
neurons flying in them, but what I mean is being able to react in real time to unfamiliar situations
If we're
is
under
a
it to
really
like
is a
this
really powerful.
if Australia's under attack or there's a missile lock or something crazy, maybe I don't know, and there's limited
Maybe.
information.
No, I think I like the idea of environmental modeling better myself.
Yeah, yeah. Okay, so,
And then obviously there's the also the sort of educational aspect where you know with more investment in infrastructure for us,
yeah.
um, we can potentially provide anyone who wants access to be able to explore the system. Much like how everyone has a computer at home, maybe everyone will be able to access the cloud one day.
Oh, and they'll be able to
Um,
access the biological computer. Yeah,
yeah, yeah,
yeah.
exactly.
Oh, awesome. And
At the moment, I mean, we're not there yet where everyone could have one at home, but
could it
with
get
some
there?
technological, I
Yeah.
think it could. I think it could. I mean, there's a bunch of sort of technological hurdles, but I don't think they're insurmountable technological hurdles.
Okay.
So I just think that the drivers haven't been there to develop that technology.
Okay.
So mainly what I'm talking about, the technology that I'm talking about is mainly keeping neurons alive with
Yes.
minimal
Energy.
input
Or
from us. Because you
okay.
have
Yeah.
to feed them and look after them, kind of like a pet or a plant or something like that.
Yeah.
I
Yeah.
shouldn't probably say pet because they're not actually conscious or I mean
No.
they're living cells, but they're not conscious or anything like that. So you do have to feed them nutrients to keep them running. That's how they get their energy. And until we get a way where, I mean, to have it used in your own home, we'd have to have a way to be able to basically have someone come in and swap it out, or be able to swap it out yourself with the either fresh neurons or be able to feed them somehow without all the technical, skills required.
But could you
So
scale it? Could you scale it that like you have your cloud service, like you have a massive neuron farm, say
yes, yes,
hypothetically. Yeah. And then
yes,
yeah.
yes, absolutely. So
Yeah.
we if you can see this side. See
Yep.
here, that's server racks
Yep.
full of CL1s.
Yep.
So that's the sort of center that you would see, much like a traditional cloud-based system where you have server racks everywhere. We have racks of CL1s. So
Oh,
we actually
awesome.
have a couple in our lab. I have a couple in our lab at the moment, full of CL1s.
Oh, awesome.
Um, yeah. So
And then
our Cortical Cloud is due to launch in the fourth quarter this year, so soon.
oh, great.
We're almost at the fourth quarter, but
Yeah.
hopefully that'll be launching very soon.
Then in just like in terms of then like obviously yeah as you're saying sort of mentioned before then like how this is just sort of another more commercial based question. How do you think like some business leaders would think about partnering with you or investing in the space perhaps to expand your cortical cloud or even yeah help with progress on your
Um,
side?
Look, I mean, we're open to investment.
Yeah.
We're not publicly listed, obviously, but we
No.
are open to investment inquiries,
Yeah.
and they go through our CEO.
Yeah.
So people can just log onto the website, send a email through one of our channels.
Yeah.
Um, in terms of getting on board, now companies can do several things, right?
Yeah.
They can engage with us directly. We can
Yeah.
actually do contract research for them
Oh, cool.
at a cost, but we can do that to get them started to see if they think, oh, is this worth our time to invest further?
Yeah.
We do like little proof of principle type projects and things, so people can sort of dabble without needing the resources as such, apart from obviously covering the costs. Um, After that, we can actually work with companies to give them their own systems, like their own CL1s, or we can work with them to get them onto the cloud. If they wanted to, and they have the expertise or willing to invest in the expertise, they could have their own rack of CL1s and have their own cloud for themselves. So there's no real roadblocks for anyone who wants to get into on and working on the technology. We want people to work with the technology.
Yes,
So,
exactly.
and again, and with the same with the cloud, any data that goes into the cloud, we don't own any of that data. That's your data. That's
Oh,
your
great.
that's your scripts. That's your algorithms, your scripts, whatever you're doing. You're just feeding that in. We're just providing a way for you to do it. So we don't take ownership of any of that. That's all your information.
Yeah.
It's like that's
Excellent.
like as you said, when you work on your computer, you write a program. That's your program, right?
Yeah.
So
I think
That
this,
that's where
especially
it's targeted.
this cloud, especially when it comes out in we said this quarter or coming quarter, fourth quarter. I
Yeah,
think that will be an exciting time for you guys. Once you actually,
absolutely. We actually have thousands of people, literally thousands of people on our list.
really,
We're not going to be able to get thousands. We're not going to be able to get thousands of people going at once.
no,
So we are going to have to ask people to be a little bit patient while we get them through. But certainly, the interest is there.
yes,
Surprisingly, though, it's like we thought there'd be some interest, but not thousands of people interest.
I reckon though it's
So,
probably maybe. Do you think it's tied with chat like the whole AI trend movement? Do you think that's why there's so much interest? Or
maybe
yeah,
it might be. It's something new.
yeah, something new.
Um,
Yeah,
so people are also curious, um, but also with things that are new. If you like, the intellectual landscape is very open.
yeah,
So if you have a good idea, you might come in with a good idea, and you've straight away got intellectual, no sort of or minimal IP
yes,
issues to think about if you're wanting to commercialize like an algorithm or a program
exactly.
or something that you've got the neurons to learn and you've got the output of that,
Yes,
whether that's an LLM or whatever.
exactly.
So it's very uncrowded, I'll say, at the moment with in terms of what you want to do with the system.
It's a blank
Does that make
canvas,
sense?
basically. Yeah,
Yeah,
blank
yeah.
canvas. Yeah, yeah,
I mean, there are a few, there's a couple of little bits here and there, but it's largely it's open. So
exactly.
if you're a company and you're inclined to go down this route, there is scope for being able to generate intellectual property in that
Exactly.
space, or using the system to benefit your own existing systems.
Exactly. No, awesome. Okay, cool. Well, I'll just stick to time here. I think we've got about another 10 minutes left. But cool. So I just wanted to ask a question about, I guess, the ethics and I guess the responsibility and how do you think about the ethical dimensions of trading and scaling biological intelligence? Obviously, you've got a little neuron dish or whatever you like, if I
Yeah.
described it correctly. What do you think about the ethics around that?
Well, I mean, we take ethics really seriously in the company. We actually are
Yeah.
actively involved in the bioethics space.
Yeah.
We work with bioethicists, internationally recognized bioethicists, and publish in the area. So we're always keeping our mind on the ethical implications of our work.
Yeah.
Now, one thing you'll often hear, and especially when people start talking about organoid intelligence,
Yeah.
um, which is like people often call these organoids like mini brains, for example, is a very common colloquialism you'll hear, um, which gives the complete wrong impression because an organoid is not a mini brain. But it's just easy for scientists to go, it's a
Yeah.
mini brain. Um,
Yeah.
but anyway, so these sorts of things, you do have to be aware of the potential for so ethically grey things to come up, and that's why we need to be actively discussing what's ethically acceptable, what's not.
Yeah.
So, for example, if you were to find that the cells became conscious, okay, and
Yes,
we're
exactly.
actually conscious. Now it's incredibly unlikely that the cells would be conscious in our system
Yep.
because they don't have the structural complexity of a brain,
Yep.
okay, and they don't have all the different cell types of a brain, so they don't really have the ability to function as a conscious brain,
Okay.
okay.
Yeah.
But we always have to be willing to. We don't actually know if this. I mean, logically thinking, it
Yes.
shouldn't happen, but we always have to be mindful of. Well,
Of
what if
course.
it did happen? And we detected it, right? So, you know, and you've got two sides to this argument, right? So, if you did discover, for example, that the cells were conscious, which they're not, not yet.
Yeah. Not yet.
Maybe they will be one day.
Yeah.
I really don't know. We don't know
Yes.
the answer to that. But if you were to say either cultured cells, which are like brain flat on plastic, or an organoid, which is like a ball of neurons, and a few other cell types, if they were to show that they were conscious, then you could go, well, okay, wow, maybe we'll stop this right now.
Yep.
But then on the other hand, you've got a concept where these are not, and this is something for the ethicists and the scientists and everyone to discuss, but you actually have something there that you can then begin to understand consciousness. Okay,
Yes.
and that becomes then a powerful tool to understand a whole range of aspects of neuroscience, psychology, psychiatry, and you sort of got to go, all right, so if we have this model that you can have a model of consciousness, for example, that's not an actual person, is it better than to use this rather than a person or an animal that's then a that to use that to study and find treatments for diseases rather than experimenting on people.
Oh, I
Okay,
see. Yeah, yeah,
it's
yeah.
one of these sort of what's one of these sort of ones that again that's it's one for discussion, but there are certainly guidelines in place already for similar situations. For example, if you're talking about stem cell work, there's limitations, certainly in Australia, where there's a very good ethical,
Yes.
overreaching
Committee.
ethical
Yeah.
committees and laws as well.
Yes.
Um, but you have, for example, with stem cells, if they develop a certain way, I'm oversimplifying this far too much, but they develop a certain way where it looks like they might actually be forming an embryo, which is theoretically possible, right? But there's already laws in place to say, well, if this happens, right, you need special licensing to continue that work and extra oversight on what you're doing. Okay. So there are guidelines in place. So we might find at a point where if we were to discover consciousness, which again, they're not conscious, they have cognitive ability, right? Cognition and consciousness is different, right? So cognitive ability in that they can learn, but they're not conscious in terms of like being aware, self-aware, or being like a person or a higher order animal. But we might need to get to a point where we have that discussion and go, all right, is this acceptable under regulation? Is it not acceptable? And that's why we do engage in the ethics space, because we want to help these discussions and guide the discussions to the point where we can actually make decisions around this.
Obviously, like with the neuron, the small peak. The way that I imagine it, at least, and correct me if I'm wrong, is you've kind of got a small like plate or something, or like a petri dish or something, where you've got the neurons that are working there in cognition or in a consistent way with the silicon chips. Is that where we are at the moment?
Yeah, essentially. So we put the neurons in these dishes that we call MEA chips.
Yep.
So what that stands for is micro electrode array chips.
Yep.
And inside these plates are all these tiny little electrodes.
Yep.
And it's through those electrodes that the neurons send their signal. Okay.
Okay. Yep.
So think of it like the neurons are sending an analog signal, okay, through
Yes.
the electrodes. That's hitting the computer side of things, the
Yep.
silicon side. We're
Yep.
converting that to a digital signal. It's doing its computational things depending on whatever environment you're using, whether it's Pong or something else.
Yes.
And then it's setting it back to an analog signal to send back out to the neurons. And that's like the closed loop where we're getting the neurons signaling, the computer signaling to each other backwards and forwards. And that's how all the magic happens, if you like, all through these little electrodes.
In your view, where does Cortical Labs fit in the global AI race, and what role will Australia play in the shaping the field?
Yeah, I think Cortical Labs is technology is really complementary to traditional AI.
Yep.
We're not competing with AI. We're
Yep.
we're providing an alternative compute method. So
Yep.
we're providing biological computation as opposed to silicon-based computation. And the
Exactly.
idea is that we want to sort of grow alongside traditional AI and use the biological intelligence to help grow that field, but also to help grow other fields. Now, in terms of how Australia can help, what role Australia play? I mean,
Yep.
Australia could be a leader in this field.
Yep.
I mean, we're in Australia. We've got the first commercially available biological computer,
Exactly.
but we need investment from the
Yep.
government. We need investment from industry to
Yep.
really grow. And if Australia can do that, then we can be the leaders in this field for quite some time. But also, we have a very strong scientific, engineering, and ethical landscape, which makes it an ideal environment to undertake this kind of work. Um,
Yep.
at least in terms of the sort of higher end stuff. Manufacturing is obviously something that's not been great,
Yeah.
but we get by. But it would be good to have the government, particularly, provide support for manufacturing, to keep that in Australia. Unfortunately, that doesn't happen right now. But yeah, if the government were to come in, I'm sure we'd make it work.
Because this, and you say this is the only, yeah, is this the, so is it right to say that you say this is the only commercially available computer of its kind at the moment?
Yes, it is. That's right.
Okay. Okay.
There is a couple of other companies. I won't name for obvious reasons.
That's all
No,
right.
there's a couple of other companies that offer a cloud-like um, environment, but no
Yeah.
one that has the accessibility that we have and that we're aiming to improve.
Yeah.
So we really want people to get access to the technology, and that's our goal. And
Yes.
the other companies that are sort of dabbling in the space aren't really following that. It's about them, not about everyone else. You know,
Yeah.
I hope I don't annoy too many people or anger anyone saying that, but that's my sort of my opinion of how I see things.
Yes.
And I mean that's part of the. I mean we were due to launch our cloud um, the last month, and
Yeah.
what we decided was that we were going to delay it because we wanted to make it even better in terms of usability. We wanted
Yes.
it to be easier for people to just come in and use without having to have years of technical experience under their belt in terms of like
Awesome.
computer technical experience. So that's the whole reason for it. And I mean,
That's awesome.
we have a GitHub. We have a GitHub. There's a Cortical
Yep.
Labs GitHub, and
Yep.
people can jump on that and already start seeing how to use the system.
Yep.
Right? We have a an SDK on there it's set up as a simulator, so it has. I
Oh,
mean, all the
awesome.
documentation's there, but that's
Yeah.
so people can. So while people are waiting to get access to the cloud or waiting to receive their units, they can
Yep.
already start working on their programs, right?
Oh, awesome.
Or their interfaces, or they can start working on how do we get the SDK to work with our systems that we already have. Okay, so people can already start doing that stuff.
That's
That's
awesome.
freely available, and the I mean most of the coding's based off Python, so
Okay. Yep.
it's pretty easily adaptable, I think, for most people.
Okay, awesome. Well, no, that's great. Okay, so people can get started using it now. You're making it more. You're still, I mean, you're almost launching. You're making it more accessible. But I will be very excited to
Yeah,
see, especially with all those waitlist clients. You said 1,000
yeah,
or thousands? Did you say or 1,000?
thousands. I'll say
Yeah,
thousands.
yeah.
I think it was last I heard it was about 3,000.
And that could
Um,
be what healthcare, fintech, or like we don't
could be
know. Or
anything.
yeah,
Could
yeah,
be
yeah,
anything.
yeah, yeah,
I do have contacts with probably 10% of people who are going on the cloud.
yeah,
Um, because people can just go on our website and sign up.
yeah, yeah.
So I don't necessarily talk to them myself. But I have spoken with quite a number of people who have gone on to sign up to the cloud. Uh, I
What-
mean, we're already shipping physical units out.
Yeah.
So we've shipped some within Australia. We've shipped some overseas. So that's happening regularly.
And so
Um,
is that like a what, a 4x4 sort of like machine or something?
yeah,
Or
wrong
oh
side.
yeah,
This
sorry.
side.
Yeah,
That there.
yeah.
Can you see that there? That's it.
Yes. It almost looks like
So
something off Theranos, or have you seen Theranos? The not to give it
yeah,
a yeah, it looks like one of those things you put, yeah, it's like that's awesome. Yeah.
yeah. And it's literally the size that it shows in the picture there.
Yeah.
It's a sort of small benchtop device.
Yeah.
Um, yeah, and I mean, we do sell those, and the more people buy of those, the better we can do the price, obviously. But
Yeah.
um,
Yeah.
I mean, the technology um, is derived out of sort of standard electrophysiology, but we've obviously done a whole lot more with it.
Yeah.
And what I'm really actually quite happy about is that the system actually is cheaper than the nearest electrophysiological system.
Yeah.
It's cheaper, but does more. So
Love that.
um, it's kind of good from that perspective. Anyway, that's something else that we were very successful in doing was bringing the cost of the system right down to about. I think when it started, it was. I won't go through numbers, but it's less than 10% of when we first started developing it. So it's really come down quite a lot in the cost of goods.
Oh, awesome.
So
Well, I mean, exactly. I said, so you're starting to sell them next month or in the next few months, you said? Or
I don't know. We're already selling them. We're already selling them.
okay,
They've already
cool.
shipped.
Okay.
Our
Okay, good.
first customers have received them, and they're starting to use them. So
Awesome. Okay, great. And then yeah, sorry, the cloud feature is
the
coming in the
cloud's
next
cloud's
few months.
coming, and then um, uh, uh, we also have the contract research service, which has started.
Yeah,
That's a little bit more sort of bespoke, if you like.
yeah,
That's called Cortical Discovery,
yeah.
and that's very much a by negotiation. We discuss and set up a project, and we all make sure everyone's happy,
Yes.
and then do the project. So that's the other option that we're providing. So we're just really
Awesome.
we're providing the systems for people who can use them, providing the cloud for people who can't grow the cells or don't have the facilities to grow the cells, and then we've got the contract research for people who can't do any of it or
Yeah.
just want to handball it off to someone else because they just want to see if it's going to work. If their
Yes.
idea is going to work. So we do
100%.
cover. We're trying to cover all the main scenarios by doing it this way. So we're not really trying not to limit people from accessing the system
Not at all. It
as
sounds
much
it
as
sounds
possible.
like yeah, no, it sounds like a blank canvas. People can create their own destiny, which is awesome. Um,
Yeah.
Great. And we'll close out the podcast in a minute, but I've just got a bit of a left of field, not that left of field question, but a bit
Mhm.
of a random question. So for the future of like, I know it's kind of ties into the future of AI, but obviously with these, large data centers or large LLM centers, they're going to be quite power intensive. Do you see a future where,
Yeah.
this silicon mixed with these neurons or biological form of computing could reduce the power consumption significantly, and perhaps we could even be powered by
I,
renewable energy? Yeah.
certainly our systems could be powered quite easily by renewable
Yeah.
energy. It's very,
Yeah.
very low power. I think it's about 20 watts um, off the top of my head.
Yeah.
And that's way, 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 way less than even like your standard PC, which is running like if you're talking about a desktop computer, 650-watt power supply, maybe 1,000-watt power supply if you've got a big graphics card in it.
Yeah.
Big
Yeah.
GPU running AI on your desktop. So it is low powered compared
Yes.
to your traditional system.
Could
But
that?
saying that, as I mentioned, we're still just building the
Yeah.
technology, so
Yes.
we don't know where it's going to go in the end. But yes, it could answer some of the issues about power consumption. It's
Yes.
certainly for training. We believe that there is a scope for training to be done through our system and sent into an LLM. So that way, the training costs should come down a lot. Less
Yes.
resources need to be put to training your next model, which means more resources are available for the actual use of the model of your LLM. So
Yeah.
I mean,
Awesome.
and there's more outside the LLM. There's image recognition and
Yep.
sound recognition, uh, sensory type situations. So it's I mean, people talk about AI agents. I mean, whether whether we go down that track, I mean, I don't know, but whether the neurons could be useful for something like that, maybe. I mean, that's one of the things we say we don't know the limits
Exactly.
in terms of what is possible. And I think if you had asked um, Apple or Microsoft back in the day,
I would
Intel
have.
back in the day, they all
Yeah.
started somewhere and
Exactly.
started small and didn't really know what was going to happen. But look,
Apple.
look,
No.
look at Nvidia. Look at
Yeah.
Nvidia. When
Exactly.
they started, they thought they had this niche product
Yeah.
that
For
all of a sudden
gaming,
was
wasn't
taken
it?
up.
Was it for
It was, it
gaming?
was actually before that. It was for I believe it was for engineering applications.
Okay. There you go. Yeah. Yeah.
I probably got that wrong, but I believe
That's
it
right.
was, it's for science and
Yeah.
engineering,
Yeah.
and really sort of niche stuff. And then all of a sudden, they went to know that gaming would go crazy, PC
Yeah.
gaming go crazy, and then suddenly, they're making a mint from games,
Exactly.
um, and then AI, because your GPU computing for the AI is it's I suppose you can include cryptocurrency in that too. So
Yes.
it's they wouldn't have been able to foresee that when they started. So
Exactly.
uh,
Exactly.
if all of us could, we would have all bought shares.
Yeah, that's right.
So,
Exactly.
I mean, I guess that's it's a similar situation. Not to say that we're going to end up like NVIDIA. It'd be really nice if that happened, but um, we don't know where the technology will go.
Yes, but
It
that's the
certainly
exciting
has
part.
its uses, but it
Yeah,
hasn't. Yeah, exactly.
yeah.
And that's what keeps me like really excited working at the company. It's just like you're always hearing these new ideas and these fantastic ideas that people want to implement. And yeah, it's really really. I'd be absolutely ecstatic to see where we're at in 5 years' time. It's going to be, I think, really amazing.
It'd be awesome.
Some of the projects I can't talk about that I've heard about just blow my mind. It blows my mind.
Love that. I'm excited to see like we come to fruition in the next few years then, and what
Yeah,
happens
yeah,
with it.
yeah,
Yeah.
yeah. It's certainly and yeah, the more people that can get on board, the better the technology can be implemented and grow. So
Awesome. I love that, Duncan. Well, thanks so much for the interview.